Hello students, in this video I am going to explain the example that you have to solve for the AVL tree. Normally the question asked in the exam is the construction of AVL tree from the given input, or the tree is given and you have to convert it into an AVL tree. So let us understand one problem so that you can solve any problem in the exam. So consider an empty tree and nodes are inserted in the following order: 5, 16, 78, 45, 2, 10, 18, 30, 50. Construct AVL tree. Label rotation at appropriate stages. So you have to construct the AVL tree step by step, inserting one element at a time, just like a binary search tree, but you have to look for the balance factor at every step. Okay, so it's very simple. Let us start solving this problem. So this is your input 5, 16, 78. So you have to insert in the same sequence. So your first root node is 5. So insert 5. Its balance factor is obviously 0. Then you have to insert 16. So if 16 is greater than 5, so it's a right subtree. Write down the balance factor. Then go for the 78. As soon as you insert the 78, it has become a right skewed tree. Okay, so if you remember the examples that we discussed in the rotations, okay, try to compare this diagram with the rotation examples that we discussed. So here the newly inserted node is 78 and the unbalanced node is this 5. Okay, this newly inserted node is on which side? It is on the right side of the unbalanced node. So, which rotation you can apply? Here you have to go for which rotation? Left rotation. Yes. So, after applying the LL rotation, what is the new tree? The 16 becomes the parent node, 5 goes on to the left and 78 on the left side. So, you have to move the element to the left one at a time. Okay, so you will get the new tree as this balanced tree, right? Now, what is your next element to insert? Is 45. So, where you can insert this 45? It is the right side of 16 and the left side of 78. So, let us insert it. So, 45 is inserted on the left side of 78, correct? Now, write down the balance factor. It is 0. Here it is 0. The balance factor is height of the left subtree minus height of right subtree. So, it is now minus 1. Do you need the rotation here? No. Why it is no? Because the balance factor is 0, 1 and minus 1, which is allowed. Now we go for the next insertion, that is 2. Where you can insert the 2? It is on the left side of 5. So it is here. Now check the balance factor. Is there a rotation required? No. Go for the next step, that is insert 10. So insert 10 means it is on the right side of 5. Check the balance factor. Again, no rotation is required. Go for the next, that is 18. So, as soon as you insert 18, there is a unbalanced node, that is 78 is unbalanced. Its balance factor is 2. So, here which rotation you choose for making it a balanced tree? New node is inserted on which side? It is on the left side of, all are in the left side. So you need right rotation. So simple. So you have to apply the right rotation. So you have to apply this rotation only for this part of the tree. The other part is remain as it is. So it's very simple. So it's a 16, 5, 2, 10 is remains as it is. Only there is a shift to the right here on this part. So it is 45, 18 and 78. Now check the balance factor. Now it is a balanced tree, correct? Now go for the next element, that is 30. So 30 is inserted on this side. Okay, left side of 18 because it is less than 45 and greater than 18. Balance factor is not disturbed. So no need of rotation. So after insertion of 30 and 50, no rotation is required. Clear? So this is the final binary search tree, which is a balanced binary search tree, and it is also the AVL tree. Clear? Okay, so now we go for the next example. This example is asked in the exam May-June 2018. Construct an AVL for the following data. Okay, the data is nothing but the months of the year. Show the balance factor of each node and the type of rotation. So you should be now very careful. You must know the alphabet sequence A to Z. So you have to check the sequence here. So first is your root node, that is March. Then May. May goes to the right side. Then November after M. This is a unbalanced node. Okay, so you have to apply the which rotation? Left rotation, right? So all are on the right side, so you have to apply the left rotation, opposite rotation. So you have to remember in this way. If all the elements are in one direction or in one side, if it is right, then you have to apply for left. And if all elements are in the left sides, then you have to apply the right rotation. Okay. So this is after rotation you will get this tree, which is a balanced tree. Then next is May, March, May and November. Then you have to go for August. August is all obviously goes to this side. August and April. May, March, August and April. And then November. Check the balance factor. 0, 1. For this is 2 minus 1. So it is 2 minus 0, it is 2. Then for May it is 2 and November it is 0. Now which rotation you are choosing here? Which is unbalanced node? March is unbalanced node. You have to apply the rotation. So here you have to go for which rotation? Right rotation. So apply the right rotation. April, August and March goes to the right side. May, November. So it's a check the balance factor. 0, 0, 0, 0 and 1. It's 2 minus 1. So it is 1. Then next is insert Jan. So Jan is coming which side? This J is less than M, greater than A, less than M. So it is coming on this side. Okay. Left side. So you check the balance factor. Which is unbalanced node? May. Yes. May is a unbalanced node. Now what you have to do is see the path. Okay. So Jan, after inserting Jan as a left child of the intermediate node, March and August. The March is a right child and it is a left child. If such thing has happened, you have to go for double rotation. Single rotation is not sufficient. So you have to first go for the which rotation? Left rotation followed by the right rotation. So it is called as a left-right rotation. So in short, you have to bring this March with here May and you have to shift it on the right side. So left-right rotation. So March, you are coming here. August goes down. Okay, and then you have to go for right. So it is March, August, April, Jan, May and November. Okay, so first you have to go for this rotation, which is it is a left rotation and then followed by the right rotation. So you will come with this as a tree. It's a double rotation. So double rotation is little bit difficult. Okay, so you have to do it in a step. You go for left rotation and then right rotation. Also check the binary search tree property. So here it is check the BF. Balance factor. Now it is a balance tree. All values are 0 and minus 1. So go ahead. Then insert December, then June and then Feb. After inserting December, no change in the balance factor. If after inserting June, it becomes a balance, and even after the Feb, now we'll see. after inserting the Feb, whether the balance vector is updated or not. Let us see June, then the Feb. Check the balance factor. It is 0, 0. All the leaf nodes are 0, right? Then you have to go for -1. January is 1. 2 minus 1 is 1. Then 2. 1 minus 2 is 1 minus 2. 1, 2. Yes. So 1, 2 and 3. Okay. So 1 minus 3 is -2. Height of the right subtree is 3. Okay. So it is -2, -1 and 2. Here there are two unbalanced nodes. One is August and second is March. So this Feb is coming on this side, right side. So you have to mostly go for left and then followed by the right rotation. So let us see. August is unbalanced, December and August is get swapped. Okay, and you have to do the left rotation. So it is August is moving to the downside, left side. April, December, Jan, Feb, June, March, May and November. So you have to, this is a unbalanced node. So you have to use it with the double rotation, right left rotation. So it is right and then followed by the left rotation. So this is your December, June and Feb. Now what is remaining? All are finished. Okay. So all elements are inserted and you are coming with the final answer. July is remaining. Yes, July is remaining. So you have to insert the July. Check the balance factors. There is a problem. Here it is unbalanced. So you have to swap it with the Jan. Okay. So update it. Do the left right rotation. Double rotation. Go to the left and then the right. So left and then right. So March is coming to the right side. Jan is going to the right. So it's a root node. Okay, and accordingly you have to update the nodes. Then next is calculate the balance factor for each node. So at every step you have to go for the balance factor. Then go for insert October. Okay, so inserting October, calculate the balance factor. So there is a unbalanced node is here. It's a May. And all the nodes of this is on this side, right side. So you have to do the left rotation. It's very simple. Single rotation. No need of double rotation. The other part of the tree is remain as it is. This part is remain same. Only the rotation is applied here. So we will come up with the new tree as November, then May and October. So left rotation. Calculate the balance factor. Then insert the September. So September is coming on this side. Check the balance factor. Is there any unbalanced node? No. So this is your final tree or answer to your question. Okay, so I hope you understand how to construct the AVL tree from the given data. Okay, and for the references, there is one site is available which gives you the visualization of AVL tree. Okay, so you can see this visualization by typing this URL. Okay, so I'll demonstrate this site in some other video. Okay, thank you.